The diagram above shows two waveforms, x and y. If the frequency of x is 30 Hz, find the frequency of y. Now we have two waveforms here, x and y. Now if you observe, they both have the same time of travel but different vibrations. Here for x we have this moving like this, just one wavelength. Here we have this and we have this. It has vibrations as well. The first one here. How do we solve this question? Solution. First of all, you have to know this, that frequency in this case will be number of vibrations over the time of travel. This formula will go a long way in solving this question. Number of vibes over the what? Time of travel. Now we can still have this in this form. So I haven't known this. Let's now look at number of vibrations for the first one. Then we now have for the first vibration x, the wavelength here is 1. So we can say number of vibes for x, the wavelength is 1. Either I write just 1 or I write wavelength. Anyone is okay. Either I write wavelength or I can write number of vibes of x is what? 1. I'll still get the same answer anyway. For the other one, for y, number of vibes here is 1 wavelength, 2 wavelengths, and we have 2.5. Let me see, 1 wavelength, 2 wavelengths, and 2.5 wavelength. Let me see. So I have number of vibes for y is 2.5 wavelength, or we can say number of vibes is what? Just 2.5. So let's see how it goes. I haven't set this. So from here is now getting more simpler. Now since we have the same time of travel, it means that no matter how this wave travels, they will all stop at the same time. So it means that the time of travel is what? Constant. Therefore the formula will now be what? We have F equals to what? N over T. We'll now be having a formula that have a constant T time. Then we'll now be having T will now be equal to number of vibes over frequency. So because you have the same time of travel, so we're going to have two cases in terms of what? Variation. So let's see how it goes. So we're going to have the first one will now be what? N of x over f of x is equal to N of y over f of y. So let's go. Now N of x is 1. F of x is 30. Is here already? Is 30 Hz is equal to N of y is 2.5 or 2.5. So I have 2.5 all over. This is now what now? F of y. We are asked to look for the frequency of what? Y in the wave movement. So 2.5 is what? 5 over what? Over 2. So we can multiply this way. So now be having f of y, the frequency, is now equal to 30 multiplied by 2.5. So mathematically, my f of y will now be 30 multiplied by 5 over 2. So my f of y, the frequency of y, will be 2 here 1, 2 here 15. So I'll be having 15 multiplied by 5, and the frequency of y in that wave will be 75 Hz. 75 Hz, QAD. So this is how we solve waves that have different waveforms and travels at the same time, irrespective of the vibration. Thank you for your time, and God bless you.